question 1. So the instructions are sketch an angle in standard position, mark the reference angle, and find its measure. I'm going to try to write as nice as I can, guys. Like I said, I'm writing on my laptop here. I'm not turning it into a tablet, so I'm going to write it with this upside here. So here we go. So first thing you do is you get a grid. So I guess I should make every grid black here. And then pi over 5. Well, remember, I'm going to go ahead and mark these. I'm going to say that's pi over 2. I'm going to say that's pi. I'm going to say that's 3 pi over 2. And I'm going to say that was 0 and 2 pi once I do a whole revolution. So I probably should have started with that. And then next, well, pi over 5, well, that's the same thing as saying 1/5 of pi, correct? So 1/5 of pi is probably something like right there. And it doesn't have to be perfect, guys. So there it is, pi over 5. And they also want my reference angle. Since I'm in quadrant 1, the reference angle is going to be the same, guys. So theta r is going to just be pi over 5. Did that make sense to you two guys? Okay. Let me constantly be checking to see if anyone wants to come in. No. Okay. So remind me every now and then if we have extra people here that want to come in here. All right. So 6 pi over 15. I do my little grid, and then I say, okay. So let's start. I'm going to say that's 0. I'm going to say here's pi over 2. This is a pi. This is a 3 pi over 2. And this is a 2 pi. So maybe this helps like that. And then you look at this 6 over 15. And then you ask yourself, is 6 over 15, let me see if I can draw a line there. Is 6 over 15 bigger than half or smaller than half? Well, if it were 6 over 12, that would be half. So 6 over 15 has to be smaller than half. Does that make sense to you guys? So that graph, this one must be in quadrant 1 again. And there it is. And the reference angle has to be 6 pi over 15. You feeling okay so far, guys? We gotta let someone else in here. All right, so here we go. Number 5. So again, I start with my little grid. And I put 0, I put pi over 2, I put pi, I put 3 pi over 2, and then I put 2 pi. And then you come back over here and you say, okay, 39 pi over 20. Look how close that is to 2 pi. That is so close to 2 pi. If that would have been 40 pi over 20, well, that's 2 pi. See? So that means, remember, you always start right here, and then it does that. And it's probably really, maybe it's even closer than that, but it doesn't matter. I'm not looking for like perfection here. So that angle right there is 39 pi over 20. And what's the reference angle? Well, you guys just told me, I think. Well, I think I told myself there. So the reference angle is right there, that in green. Look, I was just 1 away. Do you guys see? I was just 1 pi over 20 away from being a full 2 pi. So my reference angle is this one in green, is just going to be pi over 20. Because 39 pi over 20 plus pi over 20 gives me 40 pi over 20, which would have been 2 pi. Does that make sense to you guys? Okay, you could have always done, if that doesn't make sense to you guys, you could have always just done 2 pi minus 39 pi over 20, and then that would give you the 1/20th of pi. All right, let's keep moving. We're going pretty fast. We're already in number 7. We got our first one that is a negative one here. So again, here's my grid. Now I have a negative angle. So let's see if we can, let's label our stuff so we can label our negative angle. So here's 0. This is going to be negative pi over 2. This is going to be negative pi, and now I'm going clockwise. This will be a negative 3 pi over 2. And then finally, I'm at negative 2 pi again. Do we understand that right there, guys? Okay. So next I have that, I'm just looking at this negative 5 over 21. Okay, well, negative 5 over 21, forget about the negative. 5 over 21, is that more than half or less than half? Definitely less than half. It's like 1/4. You know, maybe, well, it's a little smaller than that because of the 21 there. It's not 5 over 20. But you guys know what I mean. So it looks something like this. There it is. That angle there is a negative 5 pi over 21. And then your reference angle can't be negative. The reference angle is this in green, which, yes, it looks like it's the same, right? But you just say theta reference is 5 pi over 21. See?
Others?
Yes.
So for those, I understand how you got the angle and the reference angle, but in terms of labeling our, like when you label the axes, do we have to label them with the negatives?
Like when you're labeling your regular theta, the regular angle?
Yes. Or because, so when you're labeling the axes, because I just labeled it with the like
Oh,
0
okay,
and
got you. I got
top
you.
one being
You don't
pi
have to
squared.
label your axes. Like when I do the 0, the negative pi over 2, the negative pi, the negative 3 pi over 2, and the negative 2 pi, I just do that for reference for myself. For now. Eventually, we're not going to be doing that at all. Did I answer your question there?
Thank you. Yes. And
Okay.
thank you.
Oh, no problem. We're good. Keep asking. All right, here we go. So the next one, I'm doing all my grids first. And then again, just for reference, you don't have to do this unless you feel like you're already a pro. Negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. I see someone wanted to come in. Let me let them in. Wait, do we have someone wanting to come in? Did anyone put anything in the chat? No, right?
Campbell just said that that was the only question she had, and so she dipped. Yeah.
Oh, okay. I got you. Sorry, miss. All right. So now I have this negative 25 over 17. And you're like, well, that's definitely more than half because this number here, well, that's definitely more than half, but it's also definitely more than a whole. Because if I had a 17 up here, 17 over 17, that would be a whole, right? Now, is it bigger than 1.5? Because 3 over 2 is 1.5. Well, I don't think so. 17, 89, 20, 25 divided by 17? No,
It's
it isn't. It isn't.
0.5, yeah, approximately.
Yeah, so this number is like negative 1.47 with a pi. Of course, you would never really say that, but you guys know what I mean. So that means it's going to be in quadrant 2, because that means I'm doing this. I'm going past that and like right there like that. Does that make sense to you guys? So there it is. That is my negative 25 pi over 17. Now I need this guy. I need this guy right here. Oh, I meant to use green. I need that guy right there. So the way I get that, you just get the difference between 17 and 25, because this would have been right here, that would have been negative pi. That's like negative 17 pi over 17. And I believe that difference is 8, right? 17, 8, 5, 6, 7, 17, 8, 9, 20, 21, 2, 3, 4, 5. Yeah. So this reference angle, theta r, is 8 pi over 17. Do you see how we got the reference angle, guys?
Can you explain that one more time?
Yeah. All I did, if you want, you can just write pi. I already know this one's pi. I know it's negative, but I'm just going to write pi. Minus 25 over 17 pi. And then I just put this as 17 over 17 like that. See? And well, now I'm going to get a negative, but just turn it to a positive. Okay.
Gotcha. Thank you.
Awesome. All right, and now we're with degrees. And you guys seem to flourish with degrees. You guys don't seem to have any issues with this one. So here it is, negative 295. So let's see, negative z, that's 0. There's no such thing as negative 0, right? 0, negative 90 degrees. Oh, put a degree symbol there. Negative 180 degrees, negative 270 degrees, and then finally a full revolution, negative 360 degrees. All right, so that means negative 295 is going to be in quadrant 1. You're going to go like this. That is negative 295. What is the reference angle? The reference angle is this guy, theta r. And to get that, you do the difference between 360 and 295. So I believe that is 65 degrees. Are we okay there, guys? All right, next one. A lot of people get tricked on number 13. That says 98 degrees, so I'm a little bit past 90. So here's 0 degrees, here's 90 degrees, and that's all I'm gonna put there. And I'm right, well, I guess let me change the color. I'm right there. That is 98 degrees. So your reference angle is this guy right here. Don't do it with the y-axis, it's always with respect to the horizontal axis. So 180 minus 98. What's that? 82 degrees. That's your reference angle, guys. 82 degrees. Are we feeling okay? All right. Next one. Negative 154 degrees. Here we go. Negative 154. Here's 0. Here's negative 90. Here's negative 180. So I'm going to stop. Obviously have to be in quadrant 3. So I'm somewhere like right. To get the difference, to find the reference angle, just get the difference between 180 and 154. 54, 64, 74, what's that, 26? 26 degrees. Ooh, now we got the big dogs here. We're almost done, guys. 5481. So to figure this out, you're not gonna do 360, 360, 360, 360. Take that number, divide it by 360 degrees. So I have my little calculator here, 5481. I'm gonna divide it by 360, and I get 15.225. So that 0.225 means that you did 22.5% of a revolution. So I'm gonna take that 0.225 minus 15 there, and I'm gonna multiply it by 360. And I get 81 degrees. So that means that I'm like right here, and that's 81 degrees. Because I'm in quadrant 1, that's also my reference angle. See? All right, guys, last one. See, this wasn't too bad. Last one, take this number, divide it by 360. So I'm going to take that number, 2746. I divide it by 360. I get negative 7.62777. I already lost track of how many sevens with an 8 on it. So I'm going to remove that 7. I would use the number that you have perfectly in your calculator. And I'm just going to go times 360. And I get a negative 226, a perfect negative 226. If you rounded, you might get like something else really closer to 26, but not quite. So again, 0, negative 90 degrees, negative 180 degrees, negative 270 degrees. All right, I'm gonna stop. So 226 is somewhere in quadrant 2 there, or negative 226. Negative 226 degrees. And then the reference angle is the difference between 226 and 180. Should have been green there. So 226 minus 180, we get 46 degrees, and that's my reference angle. How do we feel, guys?